Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. So I will show you two approaches for today, starting from O of n cube to O of n square, and I doubt whether it can be solved in O of n log n or O of n because I did not think of any approach to do so. So let's see the question at first, and this is the question which says that find the number of ways to place people one. And this problem is just the same as the hard problem of Leetcode, find the number of ways to place people two. So I will discuss both of these variations, and you see the constraint here in this problem is n equal to 50. So n O of n cube will work here. Okay, both O of n cube and n square will work here, but in the hard problem, in the second version of the problem, n is 1000. So you definitely need to solve in O of n square. O of n cube will not work. So let's see the question at first. So find the number of ways to place people. You are given a 2D array points. Okay, so you are given n points where each point is a point on the 2D plane. Okay, on the 2D xy plane, each point is there. Okay, and you need to count the number of pairs of points a comma b, where a is on the upper left side of b, and there are no points in the rectangle they make, including the border. So it means that you see, if you try to see this example, can you find 2 points a and b such that a is on the upper left of b? You cannot find them. Okay, so you can just say that there are 0 such points. But if you try to see this example, 6 2 4 4 2 6. Okay, so if you see, I will try to draw this. Okay, 6 2 4 4 and 2 6. So you have an axis and you have something like 6 comma 2 here, 2 comma 6 here will be something here, and 4 comma 4 will also be something here. Okay, and you need to find the number of pairs of point a comma b such that a lies to the top left of upper left of b. Okay, so if you consider this point as a and this is b, you see it is lying to the upper left of b, and there are no points in between a and b. That is also told in the question. That is also a constraint which is mentioned in the question. There are no other points in the rectangle, including the border. So you can consider these as a and b. Okay, so you can consider these two as a pair of points, as well as this you can consider this as a and this as b, and you can also consider that a is to the upper left of b. But if you try to see and try to think that if you place this as a and this as b, okay, so this a is also to the upper left of b, but you see the rectangle which they enclose, if you try to see the rectangle which they are enclosing, it also has another point, and you do not want that another point. Okay, you do not want that another point, so you cannot count this case. Okay, so you got only two cases and 2e will be your answer. So these two pair of points as well as these two pair of points. So I hope the problem statement is at least very clear to you. There should be no doubt in the question at first, and then only you can approach to think the correct solution. So definitely pause the video and try the question, and then only keep watching the solution. Okay, so first we will try to devise a very brute force solution to solve the question. Okay, so what can you do? What can you do? So a very naive way of solving is that you have some points on the xy plane, right? You have some points. Okay, and they may be random also. They may be random. So what you can do is that you can iterate through every pair of points. So brute force solution will be a brute force solution can be iterate through every pair of points. Iterate through every pair of points to see if they are valid or not. So once you are iterating, you see, let's say you choose these two pair of points, you need to see that whether these pairs form a manner such that this is to the upper left. Okay, this a is to the upper left or b or not. So that you can easily verify, right, by comparing the coordinates. If this is x comma y and this is x1 comma y1, you can easily verify that x should be less than x1 and y should be greater than or equal to y1. If this is true, then you can say that a lies to the upper left of b. Okay, you can say in this way. So using this criteria, you can easily verify whether a and b are lying to the upper left of each other or not. And after you get this, there may be many points in between A and B, right? There may be many points. So what you can do is that you can again, so let's say for every pair of points, you can again do another loop where you check every points in between A and B. Okay. Now check every points in between A and B. In between A and B. And if they are lying in the rectangle inside A and B, if they lie in rectangle, okay, then discard A and B as the possible answer. Okay, you can discard A comma B as a possible answer. Now, how you will check whether they lie in the rectangle or not? I guess that is also very simple to devise. Okay, so let's say you have got this point and this point as A and B, and there is some other point here. So in order to see that whether this point lies in the rectangle or not, so let's say if this is xy, as I said you, if this is x1, y1, and if some x naught y naught lies in between the rectangle, then definitely you can check by things like x should be greater than or equal to x, and x0 should be less than or equal to x1 in order to lie between x and x1, and again y0 should be greater than less than, y0 should be less than or equals to y, and y0 should be greater than or equal to y1, then you can say that they are lying. Okay, then you can say that they are actually lying in the rectangle enclosed. And if you find any point which lies in this rectangle, then you should discard it. Okay, then you should discard that possible pair of a comma b. You can say that even if a is to the top left of b, still there is a point enclosed by the rectangle, and I don't want to include that in my answer. So what you can do essentially for the brute force solution, let me summarize the brute force solution which I just explained you. Okay, so it's very simple actually. Iterate through every pair of points. So what you will do, you can go from 0 to n I, and you can go from j0 to n. Okay, and definitely points, you can just get x as something like points of I0, and y you can easily get by points of I1. And in the same way, you can get x1 y1, x1 as points of, let's say, j0, and that y also you can get similarly j1. Okay, and once you get this point, you just check the criteria. Okay, check criteria whether it is to the top left or not. I hope you can easily check that. If it is, then what you can do, you can start another loop. Okay, you can start another loop from 0 to n, and then you just check that if there any points, if there any points lying in the rectangle, is any points lying in the rectangle. Okay, so this will easily pass this question. Okay, but we will try for a more optimal solution. This will easily pass this question, but not the next one. Okay, if you try to change the link of this problem and go to this okay, then you will see that you need some n squared solution for to this, because there n is 1000, you cannot afford an n cube solution. So I will explain in such a way that it is solvable for this both of these problem. So let's try to understand what we can do. Okay, so how can we solve it in n square? How can we solve it in n square? So one thing is that one obvious idea when you see this type of points question is that you should sort the points. Okay, sort the points. And now it is also very obvious that since you are searching for points in this manner, you should sort in the increasing order of x. Okay, you should sort in increasing or remaining same. Okay, I'm trying to say that ascending order. You can try to sort x in ascending order. If there is a point x comma y, sort x in ascending order, and if x are equal, you sort y in descending order, because y is descending here, right? So you can sort y in descending order. You can also take the case of x being equal and try to see why need to sort y in descending order. Okay. Now there is a very neat trick to sort this without using the compare function. So by default, if you sort them, if you sort the points if you do something like points dot begin and points dot end, if you try to sort them, what will happen is that x will get sorted in increasing order by default, and y will all, if x are equal, y will also get sorted in increasing order. Okay, from smaller to bigger. Okay, but what if you change y to minus y? You initialize y to minus y, and then perform this sort operation. Then what will happen? X will definitely get sorted in increasing order. Okay, and then y, the absolute value of y, if you talk about, that will get sorted in decreasing order. So what do I mean by it? What do I mean by it? So let me take an example. Let's say 0, 2, okay, 2, 5, and 2, 7 you want to sort. Okay, so if you try to sort it in, I mean, just by doing this sort function without then what it will do is that it will first sort x and then y according to this order. So this will be the sorted order only. Okay, so this will be the sorted order. But if you change y to minus y, I hope you do understand what is happening, right? If you change y to minus y, you see you are not losing the value of y. Actually, you are actually not losing the value of y. You can again do a minus y and return it to the positive value. Now if you try to sort them, you will see x will get sorted as it is. Okay, x will get sorted as it is, but y will be sorted in increasing order. So this is the least value, so this will come at first, and then 2 minus 5, and then if you remove the minus signs, if you try to remove these minus signs, you will get something like this, and this you say you have sorted it in the desired order. You have sorted it in the desired fashion you want to do. You have increasing x orders, and if x are equal, you see x are equal in these two cases, then you have decreasing y order. So without writing a compare function, you can easily sort it in this way. This was a neat trick. Okay, so yeah, you can do it. You can do it. So once you have the points sorted, what can you do? What can you do now? So you see, you have the points sorted. So let's say this can be a thing. This can be a thing, and let's say this can also be a thing, and so on. Okay, and so on. So you see, if you consider the first point, and so let's say you keep two pointers. Okay, one is I, and you consider the first point, and you see that this is x comma y. Okay, and you try to now see that which other of those points will form a rectangle with x comma y, and it will not enclose any other points. So for that you keep another loop, another j loop. Okay, and let's say that is iterating through a variable point x1 comma y1. Now you see, try to do it by observation at first. Try to see this. This is holding true. Okay, there are no points lying in between this. Now you see, does this hold true? If you consider this rectangle, this will not hold true because it is not lying in, it is not to the top left. Okay, so this, if you consider this as A and B, A is not to the top left of B, so this will not hold true. Okay, this will not hold true. This points hold true and this is not holding true. Now you try to see, will this point hold true? Yes, it will hold. Yes, it will hold, because I hope you can understand, right? It will hold because you see there are no points lying in this rectangle, and if you take this to be A and B, A is to the top left of B, and there are no points lying inside this rectangle. So this will also be true. If you try to see this, this will not hold because although the A and B, if you try to consider, they lie in the top left, A lies to the top left, but you see there are some points in this rectangle. Now you can easily take the case of how A and B lies. Okay, but now I want to say that if you have, let's say you have 2 points, this is A. Once you consider some point which is this, okay, you have already sorted them. So increasing order of x, you are getting it in any manner you do. Okay, so once you get this, you see, once you get it in this fashion, I want to say that if you try to, let's say this is x comma xy, at first x1 y1 is this one, Okay. Now I want to say that once this bar for y1 has been set, you cannot select any point which is less than this bar. So if you next x1 y1 is, if it is this, you see, if you try to enclose this, you will get 1 point within this. You will get this point. So once this bar has been set, okay, once this bar has been set, you cannot select any point lying to the below of this bar. You can select points which is lying here. You see, you have selected a point. After you selected this point, you cannot, the bar has been shifted to, you see, I am talking about an imaginary bar of y coordinate. The bar has been shifted to this. Now you cannot even select a point which is lying in this, because since you are selecting a point which is less than this bar, okay, you see, you will get a point when you draw a rectangle. You will get this point, and this will make an invalid point. So you always need to select something which is lying above the bar. Okay, so you can consider this as y values. Y1, this was once a y1 value. Okay, this, I hope you can understand, this coordinate was once a y1, this was also once another y1, and you are storing y max. Okay, so the y max will give you the bar value, so you need two criteria, right? A should be the top left of B. You can easily identify that. How you can identify it? If you now you start to see, if you consider this point, this is lying above the bar. This is lying above the bar, but this is also lying above y coordinate, which is making the first criteria fail. That is, the A is not to the top left of B. So what is the constraint for y1? If you see, as I had told you, if you consider the iterating variable x1 comma y1, y1 should be strictly greater than the bar. Okay, y1 should be, and y1 should be less than or equal to this y. This y, it should be less than or equal to this y. Then only it will satisfy this criteria. So both of these criteria should hold true, and bar we can update it. Bar is nothing but y max. If you did not understand, you can definitely ask me in the comment section and try to go through the this portion again, because this is very important, and these ideas are going to help you a lot in solving these kinds of points question. Okay, so I hope you did understand what I am trying to say. I am talking about an imaginary bar which is set by the y max function, and as bar lifts up, you need to select a point which is lying above your bar. And definitely I'm talking about the case where I have shifted. So as I told you, I have two loops for I from 0 to n and j from 0 to n. Okay, so I have selected the point, first point I, where I is 0, and selected this point, and I am looking at which of my points iterated by this j variable, which is x1 comma y1, iterated by this j variable, is valid to form a pair with this A. Okay, so I hope you can easily understand how can they form a pair, and I hope you got some intuition at least of what I am trying to say. I tried my best to explain it. Okay, now it's your job to understand by watching the video again if you still have any doubt. So let's try to code it out and things will get more clear. So first I want to sort x sort x by increasing and if equal y by decreasing. So in order to do that, as I had already told you, what you are going to do is very simple and easy. In fact, points dot size, you just take an n and you go through the whole loop. You just go through the whole loop, and what you do is that you just do points of I1. You take the y coordinate, as I was telling you, in order to sort, you just negate your y coordinate. So you're just taking the y coordinate and negating it, doing nothing much. Okay, so you are just negating your y coordinate and then looking for the sort function. Okay, so you can just sort it, points dot begin. Make sure to use the correct variable, points dot begin and points dot end. So you did get a this. Okay, and now you can just do those two while for loops as I told you. You can just have, for checking every pair of points, you can just have a while loop. Now, the first point which you are considering, is x comma y as I have told you. So points of I0 will be your x, and y, what will be y? It will be minus of points I1. Why minus? Because I had again done minus. I have sorted it, and I will just put again minus to get back my original value, right? I will just get back my original value by doing minus. So I also need a y max, okay, which is nothing but the bar. I am setting it to 1e minus 9, minus 1e9, okay. So, and which gives us nothing but the bar which I talked about in my explanation. So this is y max. So I hope you understand this. And x1, I will now get the points x1 comma y1, which is a matching point for x comma y, okay, which is a matching point for x comma y. So I have this y1, and again I will do a negative of points I1. Okay, so I hope you can understand this. And I will check a simple criteria, which was that y should be strictly greater than this y max, y should be strictly greater than the bar, and also y should be less than, I mean, less than the y. Okay, so y1 should be less than or equal to y. So the second criteria says that they form a valid pair of that A lies to the top left of B, and this statement says that they do not have any other points in between them. Okay, so you just also update your answer. Let's say you do have an answer variable which is initialized to 0. Let's say here only, let's say it's initialized to 0, and you just increment your answer, and also definitely update your y max. So max of y max comma y1. So I hope this was clear to you. I don't think there should be much difficulty in understanding, because it is not that much a hard problem if you are thinking it in the correct direction. So yeah, you see we have this solution. If you try to run it and check if there are any error. So you see we do get a wrong answer for this. So let's try to see what is the error in the code. So I should start from this I plus 1, right? One thing is for sure, I should start from this I plus 1, because I have sorted it already, and I am looking for the points which are to my right. And definitely these will be j, because the iterating variable is not I but j. So a little bit analysis shows some mistakes. So yeah, this I we need to take care. So if we now try to run, you see we did get the accepted case. If we try to finally submit it and check if it works, so you see it works with our quite okay runtime and memory complexity. Both are quite fine. You are doing in n square O of n square solution, and it's not that bad. If you try to submit this question also, if you try to submit the same question, it will work for this also. It should work for this at least. So let me just replace this solution with our one. Okay, so yeah, it's almost the same one. If I try to submit it now and check if it works, see, it's a hard problem and the same description. So it is giving a wrong answer on one test case, which is it 1e9. Okay, so I did 1e minus 1e9, but what if they are equal? So yeah, I just put a negative value. Now it should work, I guess, at least for this test case. Yeah, so you see, even a hard problem, we have solved it. It is passing with this and with an okay runtime complexity. And I hope this was not very difficult for you to understand. Okay, so I hope things were really easy. I want you to try this brute force solution on your own also for a better grasp on this problem, and tell me in the comment section whether you were able to solve. I hope you can easily solve this. And yeah, that's all, I guess. That's all for this video. I will meet you in the next video. Till then, thanks a lot.